Okay, and we're all set. Welcome to episode 4 of Matt Makes a Game from Scratch. I think what we got up to last time, if we jump back into our fledgling game, is we've made a Swapchain, and it was a emotionally bruising experience because I think I might have misread or misremembered something in the spec and thought that the thing that I actually needed to get was not the thing that I needed to get, and thought it was something that was deprecated, and it was a whole heap of pain. But we now have something that we can run, and it works, and we've tidied up our dinit function, so it'll tear down as well. So that's all good. I had the spec open, and then I closed it for some reason. So I think our goal for today should be kept somewhat modest. I'll be completely honest, I'm pretty tired, and I don't know if I sound it. I think allergies have hit me today. So sorry if I sound a bit gross. But I think this is, in some ways, actually what I was hoping to get out of streaming. Is it a bit of a nudge to actually do things, even if you don't completely super feel like doing them. So I think we're into an area that I didn't fully understand going through the Vulkan tutorials, and so I'm hoping maybe walking through it a little bit more slowly here. Maybe it'll make more sense to me. So we've made our Swapchain, which means that the thing, I guess, that our graphics driver will do to interact with the operating system to get these images that are in whatever place they need to be so that we can present them to the screen efficiently. So that exists. That will have a number of images associated with it. We currently know nothing about those images. So I think the next job we need to do is we need to go and get Swapchain images, which I've skimmed quickly ahead in the spec, and we can see it just here. That will let us get a slice of images on our render estate. Now, those images, if I remember right, the VK image type is just a handle, so it just represents some area of memory that's presumably mapped to the Swapchain images. We'll then need to create image views for those images, which will give us an actual interface that we can pass them to other things with, to make use of them. And then, if I remember right, we then need to make a frame buffer for each of those image views. Now, I think the fuzzy idea I have in my head is that these image views are just it's stupid to call them views. I'm trying to think of a better word for it. I think a lot of systems languages have this concept of kind of a view onto memory. And so image views are a view that I'm assuming just mapped onto the memory that the Swapchain images occupy. And they let us read and write. I'm guessing the frame buffer, I think, is the attachment that our shaders can actually interact with. Maybe the docs will tell us that there's some really structured way that interacts with the Swapchain. Maybe it's driver dependent, I don't know. But I'm going to set that as a bit of a soft goal. That might be too much, but if we get the images and image views, I think we call that good. Anything past that would be gravy. So like I say, this is really, I think, the next chunk. And we now know we have the VKKHR Swapchain extension enabled, because that was the headache we had last time around. So have I got the layout okay if I do this again? Because I have found this pretty useful. Is there a way to say, I would like to make you fit the width? There we go. Okay. So this is all the nastiness we added last time, the many, many flags we had to go and look up. And that's the end of our function. So I guess just for the sake of sketching it out, we want to now make Swapchain images. Then probably in here we want to make Swapchain image views. And then I think after that we want to make frame buffers, and I think it's a frame buffer per Swapchain image view, but I'm not entirely sure of that either. So, I guess we just start. Looking at this, to obtain the array of presentable images associated with the Swapchain, you call vk get Swapchain images khr. It takes the device, takes the Swapchain, and it's that same little enumerating pattern we've seen time and again. So we all need a count that we don't need to actually give a value to, and hopefully we can then say res is equal to vk get Swapchain images khr for our renderer.device, our renderer.swapchain, and a pointer to count, whoops, and nil. So if you're new to Vulkan, this is a common pattern we'll see, where the first call, it needs to work out how big the thing is, we'll then allocate some memory, and then we'll fill in a value. I'm actually kind of interested to just see, though, what we get here. Can I print line count and just see 4? Neat. Cool, so we make our Swapchain has 4 images in it. I wonder what determines that. I know we pass it, I think, a minimum number. I think our minimum number we passed, it might have even been 1. So who knows? But we're getting 4 on this device on this day. With this driver, you get 4. We should do a quick check. So if res is not a success, then we're going to stick to our normal pattern of just panicking if anything ever goes wrong. Failed to get Swapchain images count. If that succeeds, then we can go ahead and allocate some memory. Actually, we might as well do straight onto the renderer. So if we come up here, we're going to have Swapchain images, which is going to be vk image. It's not going to be vk image, it's going to be a slice of vk images, and at this point we don't know the size of this, so we don't. I guess you could make it stricter, so we could make it so it's a thing that's passed in. We know what the maximum number would be, so we could make this static if we wanted, but I don't know that it makes enough difference for us to care at this point. My goodness, where is this all jumping to? So let's jump back down our thing. File's getting long now, isn't it? Make Swapchain images. We do all of this. Then we would like to do renderer. Oh my god, what am I doing? Yeah, renderer.swapchain images will be equal to make a slice of vk image with count things in it. And if we do that, we would like to then say res2 is equal to vk get Swapchain images khr, renderer.device, renderer.swapchain, pass in that same count, and this time we pass in renderer.swapchain images. That I think will be unhappy because this is a Odin slice and it wants a C pointer, which we can get at with the raw pointer procedure, like so. If res2 is not equal to success, then panic again. Failed to get Swapchain images. Runs, and it's totally happy. I'm slightly surprised that it doesn't complain about us not destroying the images. I guess it's fine with it because the images aren't actually being managed by our program, right? We're just getting handles to images that are being managed by whatever is in the operating system that manages the swap chain. So that makes sense. We probably do want to add a call to free this in our dinit function though. So where should we do that? Maybe here. So go delete renderer dot swapchain images. Yeah, because that's some memory that we've allocated, and that should not error, and it will read. All is well. Okay, so we've made our swap chain images. That didn't seem too bad. Is there anything interesting in what it's saying in here? So it gives the normal thing about the enumerating procedure. If the value of p swapchain image count is less than the number of presentable images, at most that many structures will be written. And VK incomplete will be returned instead of VK success to indicate that the... Okay, so we would be alerted if that was happening, because we don't think it should be happening. Is there anything in here useful? By knowing all presentable images using the swap chain, the application can create command buffers that reference these images prior to entering its main rendering loop. However, command buffers are not allowed to reference presentable images created with... Okay, so we're not doing that. Images returned by vkget swapchain images are fully backed by memory before they are passed to the application, as if they are each bound completely and contiguously to a single VK device memory object, unless the swapchain is created with the deferred memory allocation bit. All presentable images are initially in the VK image layout undefined layout, thus before using presentable images, the application must transition them to a valid layout for the intended use. Interesting. Further, the lifetime of presentable images is controlled by the implementation, so applications must not destroy a presentable image. Say again. Further, the lifetime of presentable images is controlled by the implementation, so applications must not destroy a presentable image. Okay, this is what we were saying before. It's managed outside of our app, so we don't have to do any destroying. See VK destroy swapchain KHR for further details on the lifetime of presentable images. Images can also be created by using VK create image with image swapchain create info KHR and bound to swapchain memory using this. These images can be used anywhere swapchain images are used and are useful in logical devices with multiple physical devices to create peer memory bindings of swapchain memory. These images and bindings have no effect on what memory is presented. Unlike images retrieved from VK get swapchain images, these must be destroyed because then you're managing them. So we're not doing that. That sounds a much more complicated use case than us. To acquire an available presentable image to use and retrieve the index of that image, you do this, and that gives us an image index where image index is a pointer to a U32 in which the index of the next image to use, i.e. an index into the array of images returned by get swapchain images, is returned. So that's why we need to keep a hold of this slice or array, I guess is what they've actually created, is that in our actual like render call where we're going to create our command buffer and submit it, we're going to have to acquire the image that we're going to write to. But I think we don't need to do that right away. Acquire next image. There's a whole bunch of stuff in here. In fact, that's a point. Acquire next image doesn't actually take an image, does it? It just takes the swap chain, and these are our synchronization primitives, semaphores and fences that we have to worry about. So that's something to think about another day. So the image transition stuff, I think we do need to worry about. So I'm going to stick a quick to do in just to make sure we don't forget about that. What exactly did it say? Acquire next image. Can you see them? All presentable images are... In fact, can we text select this? Surprised that didn't work. Does that not go onto my system clipboard? There we go. Doot and doot. So we're gonna have to go back and do this. What's it called? Layout transition. Which I think is about the memory layout of the image. But I don't honestly know what value we want for it yet. So that's on our to-dos. Now, is there going to be something in here about the image view? This is all around get next image and destroy next image. Or acquire next image even. Yeah, there we go. QPresent is how we're going to actually like submit our work much later on when we've got everything else plumbed together. What is this one? Present info, which takes a pointer to swap chains, a pointer to image indices. I can't remember why we need image views. Maybe we don't. I'm just going to keep scrolling down in case I see image view somewhere. But if we get to the end of this chunk, bunch of Google stuff, we might well actually get to the end of this chunk and have it not mention it, in which case we, I guess, just plow on until we hit something that needs the image views. Maybe it's frame buffer that takes in the image views. That's what I've got in my head. Christ, there's a lot of this. So we're into the extensions though, yeah, and then HDR metadata. Interesting. Well, they do say it's a reference, it doesn't read like a book. So I guess we have a choice now. Do we want to do this image transitioning stuff first, or do we want to what else can we do? Go look up what we do with frame buffers. I'm going to have a look for image and see if there's something about image transitions. Ah, image layouts and image views. This all sounds like it's what we're after. So let's see. Image layouts. Images are stored in implementation-dependent opaque layouts in memory. Each layout has limitations on what kinds of operations are supported for image sub-resources using the layout. At any given time, the data representing an image sub-resource in memory exists in a particular layout, which is determined by the most recent layout transition that was performed on that image sub-resource. Applications have control over which layout each image sub-resource uses, and can transition an image sub-resource from one layout to another. Cool, that makes sense. Transitions can happen with an image barrier. Transitions can happen with an image memory barrier, included as part of a VK command pipeline barrier or a VK command wait events command buffer command. Cross that. Okay, see image memory barriers, or as part of a subpass dependency within a render pass. Image layout is per image sub-resource. Separate image sub-resources of the same image can be in different layouts at the same time, with the exception that depth and stencil aspects of a given sub-resource can only be in different layouts if this feature is enabled. When a VK image view descriptor is accessed on the device, all image sub-resources must be in a valid image layout. Each layout may offer optimal performance for a specific usage of image memory. For example, an image with a layout of VK image layout color attachment optimal may provide optimal performance for use of color attachment, but be unsupported for use of transfer commands. Applications can transition image sub-resource from one layout to another in order to achieve optimal performance when the image sub-resource is used for multiple kinds of operations. After initialization, applications need not use any layout other than the general layout, though this may produce suboptimal performance on some implementations. Okay. So if we'd created the image ourselves, we define the initial layout, but we're being given an image. Okay, but it sounds like we would always set it to be undefined, unless you have some other thing. unless you have some like specific case that you're interested in. Host access to image memory is only well defined for linear images and for image sub-resources of those images which are currently in any of the following layouts. So you can call this function for a linear image to return a sub-resource layout mapping valid for either of those image layouts. How do I transition it though? And then there's just a huge long list of things it can be. The layout of each image sub-resource is not a state of the image sub-resource itself, but is rather a property of how the data in memory is organized, and thus for each mechanism of accessing an image in the API, the application must specify a parameter or structure member that indicates which image layout the image sub-resource or resources are considered to be in when the image will be accessed. For transfer commands, there is a parameter to command. For use as a frame buffer attachment, this is a member in the substructures of the render pass create info. See render pass. When do we talk about render pass? Render pass is another one of these objects that I didn't really get my head around the first time through. It felt like it was very much the kind of everything object. Let's have a quick search here then. So render pass. It's chapter 8. So maybe we're a bit ahead of ourselves. Do we need a... render pass has frame buffers in it. Okay. So maybe we are going around this in a funny order. I might leave. Trying to have a bit of a think. So we've currently got our handles to our images. My memory is that we then need to go and grab image views. We use those image views. In fact, should we jump to render pass and see? So somewhere in here we have render pass, which has frame buffers on it. And I'm guessing if we find create frame buffer, it will take in a create info that will take image views. We're looking frame buffer create info. It takes a render pass and attachments which are image views. So that's why we need image views. Okay, we might sack off frame buffers for now then. And just make image views and transition our images. Right. So where did I see image? It's back in here. And can we just do a search from this point on to find the word transition? It's going to get used a whole bunch. Huh. Did not call transition. I really want... Did it layout, I guess? Image sub-resource layout. It's a shame this isn't broken down into smaller bits. It's not, is it? So I'm in image layouts. Is it still easy to just search for everywhere it says the word layout? I thought the word they used was transition. You transition an image layout. It's not looking hopeful though, is it? So you can get it. Here's a bunch. Okay, so I'm guessing these ones with really long values, they're going to be all our extension things. I guess, are we color attachment? Or is there going to be one of these that says present source? Provided by thing. I think that's one that we want. To transition to... oh, I've lost it. Scanning. VK image layout present source KHR, and again it's provided by Swapchain, so we do have it. Oh, let's have a quick skim down this and just see if it says affirmatively that is what we want. Can we go in here, present? No, it's not that, is it? It's this. Must only be used for presenting a presentable image for display. Yeah, that's what we want. So the question now is, how do we do the transfer? Are we not going to be able to do it because we don't have stuff set up to submit commands yet? So the layout of each image sub-resource is not in a state. Oh dear. Did I mean to do that jump? Did I click a button twice? Can we jump back? Oh, it went a long way. How do I transition from one to another? Layout matching. At the time that any command buffer command accessing an image executes on any queue, the layouts of the image sub-resources that are accessed must all match exactly the layout specified by the API controlling those accesses, except in cases of accesses to an image with a depth or stencil thing. Okay. I think we have to come back to that later, because I'm just not seeing anything useful about it. But this is something that we do want to do. So, image views. Maybe you have to do the transition on an image view? Who knows? Image views. Should I just read it? It'll probably say better than I will. Image objects are not directly accessed by pipeline shaders for reading or writing image data. Instead, image views representing contiguous ranges of the image sub-resources and containing additional metadata are used for that purpose. Views must be created on images of compatible types and must represent a valid subset of image sub-resources. Image views are represented by VK image handles. So we're going to want a 2D image view created like so. So let's go back to the top. Swapchain image views. We're going to have a VK image view. We love all this easy stuff. And then it's going to be very samey. U32 res is a VK create image view. Oh, we don't even have to do a count, do we? Because we know how many we're going to do. Create info, allocator and view. Interesting. Okay, so in here we're going to need to allocate some memory for our image views. So let's get Swapchain image views is going to be make a slice of VK image view, and the number is going to be the length. Let's go cast U32, the length of renderer dot swapchain images. So we allocate out some memory for it. We call create image view. It's going to take in a renderer dot device. It's going to take a reference to a create info we've not made yet. We're not making our own custom allocator, and it's going to want the pointer for our renderer image views. Renderer dot swapchain image views. Just so I don't forget, if res is not equal to success, oops. Then we panic. Failed to create swapchain image views. And then in here we're going to make a create info. Yeah, you can go there. Which would be a VK, what's it called? Image view, create info. Ah, we're doing them one at a time. So I guess we're going to actually need to have a loop iterating over this, are we? What goes in this create info? Create info takes a structure type, an extension pnext, image view create flags, image view type format, components and sub resource range. I don't know what a bunch of those mean, but I do think we're going to need to make a loop. So let's go for I in. How do ranges work in Odin again? 0 is less than or equal to the length of renderer swap chain images. So for each of them, we're going to make a create info. We're going to do this. Panic if it fails. And that means this is not actually going to be a raw data, is it? I think what we actually want here is the address of the ith element in that slice. You can probably do that more neatly, honestly. Okay, but I think this works for us. So let's make this struct. The first thing to add will be s-type, because hopefully it's really easy. Oh, what's it going to be called? It's going to be something like image view create info. Pnext we can ignore. Flags might be interesting. It doesn't know what flags is. I really do need to sort out my NeoVim setup. Okay, let's see. So flags is a bit mask of VK image view create flag specifying additional parameters for the image view. We'll come back to that. So let's just put a to do on there. Image is the VK image on which the view will be created. We do want that. That will be our renderer. It's just a handle, isn't it? It's not a pointer. Yeah. Is our renderer dot swapchain images I. Then image view type. I don't know what that's going to be. Image view type is going to be D2. This is a 2D image view. Our format. We need to go grab that off our. I think we've not saved that in state, have we? So we need to move this into state. So format we can't get yet. Components. Specifying a remap of color components. I think this is one that has a bunch of these fields, and I think we can just pass in identity for all of them because we're not doing any weird remapping from one color to another. We just want it to actually be what it's meant to be. So I think we can just do that. Then sub-resource range. Structure selecting the set of MIP map levels and array layers to be accessed to the view. To be accessible to the view. I'm not sure quite what we do with that information. Has a bunch of stuff in it. Why has it got a bunch of stuff in it? Aspect mask. Okay. So your to do, and flags is to do. So this isn't going all that smoothly. What does this say? Some of the image creation parameters are inherited by the view. In particular, image view creation inherits the implicit parameter usage, specifying the allowed usages of the image view that, by default, take the value of the corresponding usage parameter created in the VK image create info. The implicit usage can be overridden by adding a VK image view usage create info, but the view usage must be a subset of the image usage. Aspect mask only includes this. Includes only that. If it has both. Oh, yikes. Struggling today. Okay, shall we just check that what we've done with components makes sense before we blow things up? VK component mapping components member describes a remapping from components of the image to components of the vector returned by shader image instructions. This remapping must be the identity swizzle for storage image descriptors, input image descriptors, and frame buffer attachments. And any VK image view with a combined image sampler that enables this thing. Cool. Okay, so it has to be identity because we're going to use it for a frame buffer. What's the rest of this say? Any image view plane. Oh, sorry. Christ, yawning. You'd have thought this was boring. Oh, there's so much stuff in there. What is this? Image view create flags. We do care about this. Bits which can be set in VK image view create info flags specifying additional parameters of an image view are provided by different extensions that I don't think we're using. And so our flags can actually just be empty. So we can do that without any changes. Format we know what to do with. So we'll do that in a minute. Sub-resource range, I would like a nudge on though. And it doesn't look like we're going to get it easily. So if I just scroll back up, did it have a link to anything about this sub-resource range type? Sub-resource range is a sub-resource range structure that has all of this stuff on it. Aspect mask is a bit mask of VK image aspect flag bits specifying which aspects of the image are included in the view. That didn't mean a lot to me. Let's see. So we come into here. Can we say here aspect mask is equal to image aspect flags? What are the values? Image aspect flags color depth. Okay, I'm guessing ours is just color. Plane 0, plane 1, plane 2. Memory plane, extension, plane 0, KHR is the same as plane 0. Okay, I think we just want color. So I guess that's saying what things can we use this for. Base MIP level is the first MIP map level accessible to the view. I'm going to say 0 and hope that means do nothing. Level count is the number of MIP map levels starting from base MIP level accessible to the view. I am also going to set that to 0 because we're not going to do any MIP mapping, at least not first. Then base array layer is the first array layer accessible to the view. Layer count is the number of array layers starting from this accessible to the view. Is our layer count going to be 1? Because we do, I guess if you set a layer count of 0, does that just tell it you have access to nothing? Okay, so base array layer is 0. We're just, I think this is something about for efficient memory use, more complex rendering pipelines will make an effort to kind of lump similar things together and have them all live in a contiguous block of memory, and then like index into that block to pick out different things. What we're doing is so simple, we only have one thing. I think we might actually have to say layer count is 1. In fact, if I do 0 and I run, we get a bunch of complaints. Image view must contain at least 1 bit. Format features of the resultant image view. Oh, okay, it's actually complaining because we don't have any format, which we know we need to do. So what do we need to do? We want to do format will equal, oops, wrong way. Can I do something like renderer.format? Renderer.image format? Renderer.swapchain image format, maybe? And then we'll come back up here. Swapchain image format. And then we would quite like, see what type that is. It's a VK format. And somewhere, this is where we're sorting our formats out. We get supported formats. Supported formats is all of these. Desired format is this. Desired format supported is false for all of this. Surface image format is equal to that. Sorry, at this point, am I making the surface or am I making the swap chain? I'm making the swap chain, aren't I? Can we just do that directly into here then? So renderer dot swap chain image format is equal to that. Unhappy, cannot do this of type surface format to format. Okay, so they are different. Surface image format. Ah, because that has a format on it, doesn't it? So it's the move to actually make a surface image format on state. And if we have that, should that really live on our global thing? Okay, so we've got our surface image format. We create our swap chain. If we've done that successfully, then what we would like to do is we would like to say our renderer.swapchain image format is equal to surface image format dot, oh, do you not exist? I've just grabbed the wrong thing. Surface image format dot format. So remember, right, this has a format and an extent. At least it would if my auto-completing worked. And so then you are set. Where's format? Format is now set. So we come into here and it runs sub-resource range.level count is 0. Okay, so I guess we need to have that as 1 as well. Cool. And just to check my guess, if I set that to 0, this will also complain because, yeah. What does it mean if you give it access to 0 things? It's just a meaningless object. Is that done then? Make swapchain image views, renderer.swapchain image views. We make VK image view. We make that many of them. And then I guess down here, before we destroy our... Oh, do you have to destroy these? I think you do. Can I do VK destroy swapchain? Nope. VK destroy image view. for our renderer. Oh, yeah, we're going to have to do this in a loop, aren't we? Image view. For image view in renderer dot swapchain image views. Destroy these. And it's going to need to take a device, an allocator, which we don't set, unhappy, expected 3 arguments and got 4 because I made a typo. And then after we've done that, we can delete our swapchain image views. Let's go check if that blows up in some way, and it doesn't. Okay. Going to give that a quick skim, but I think that all sounds good. So we're putting the format of the thing, we get the images off the swap chain, we make image views because we're going to need them when we make the frame buffers. Cool. Get swap chain images and make swap chain image views. Let's push. Okay. Shall we have a little investigate about this transitioning images then? I would kind of hope that this would be the sort of thing that wouldn't be that hard to find, but maybe it is. So image layouts tells me about the image layouts. Micromaps, memory association. So none of those sound relevant to us, do they? And if I just check, like I said, I remember the word being used was transition. Transition memory layout for an image. Okay. So we're already there. See, image barriers are as part of this. Transitions can happen with an image memory barrier included as part of the VK command pipeline barrier or a VK command wait events command buffer command. See image memory barriers or as part of a subpass dependency within. Oh, okay, you don't get a thing. So what do we see in image memory barriers? It jumps us backwards, which makes it sound like this is something we probably should know already if we were at this point. Image memory barriers only apply to memory accesses involving a specific image sub-resource range. That is, a memory dependency formed from an image memory barrier is scoped to access via the specified image sub-resource range. Image memory barriers can also be used to define image layout transitions or a queue family ownership transfer for the specified image sub-resource range. The image memory barrier 2 looks like this. I'm guessing 1 just doesn't have p next. What does it say? Or maybe this is something that only exists in 1.3. It has a type, is a source stage, an access mask, destination stage, a destination access mask, old layout, new layout, image and sub-resource range. So is that what we want? Or the equivalent? Okay, so this is something that did get added later. Interesting. Which means it won't have been covered in the tutorial I'd been using. Can I just see if I can find anything about this subpass dependency? Not like that, you can't. Render pass. Can we jump into here and do a search for subpass? Subass. Subpass. Dependency. So, how far in is this? 555. It's a ways in. Oh, there's a whole chunk. Oh, actually, it's right near the top. Okay, interesting. Subpass represents a phase of rendering that reads and writes a subset of the attachments in a render pass. Rendering commands are recorded into a particular subpass of a render pass instance. Each subpass can read from some attachments as input attachments and write to some as color attachments or depth or stencil attachments, perform shader resolve operations to color attachments. A subpass uses an attachment if the attachment is a color depth stencil resolve, fragment shading rate, or input attachment for that subpass is determined by these things. A subpass does not use an attachment. Okay, so I think actually this is not a thing we have to do at this point. This is something we're going to have to do when we put together our pipeline. And given frame buffers get mentioned as part of the render pass, if I remember right. Sorry, my voice is going. I'll have a sip of drink. Yeah. So if we look inside of render pass, am I losing it? There we go. Render pass has a bit in it about frame buffers, and these frame buffers. Render passes operate in conjunction with frame buffers. Frame buffers represent a collection of specific memory attachments that a render pass instance uses. And in our case, is that the difference between the Swapchain images and the frame buffer? Frame buffer is a more generic thing. So our image view of Swapchain images is an example of a thing we may wish to output to, but we might want to output just generic data if we were doing like a compute. Would that have a render pass? I don't know. That's a good question. So maybe it's not that. But anyway, to create your frame buffer, takes a frame buffer create info, gives you a frame buffer. If this doesn't take a render pass, we might be able to just do this now. Oh, it's deprecated. How interesting. I don't know what to do with that information. Well, I guess we're using 1.3, not 1.4, so maybe we just plow on, but it does feel a shame to flex your brain trying to get your head around how this works if they're just about to tear it out. Did it take a render pass? It does take a render pass, so we can't just make this naively, so we probably actually need to do that at the point we're making a render pass instead. I would like to see, though, what we're doing with this. Render pass objects, deprecation via dynamic rendering. In Vulkan 1.3, dynamic rendering extension was promoted into core, which added a new way to specify render passes without needing to create a frame buffer and render pass object. However, subpass functionality had no equivalent, meaning dynamic rendering was only suitable as a substitute for content not using subpasses. In Vulkan 1.4, however, dynamic rendering local read was promoted into core as well, which allows the expression of most subpass functionality in core or extensions. Any subpass functionality which was not replicated is still expressible, but requires application to split work over multiple dynamic render pass instances. Functionality not covered with local reads would result in most or all vendors splitting the subpass internally. Outside of Fender extensions, applications are advised to make use of VK command begin rendering and VK command end rendering to manage subpass renders. To manage render passes from this API version forward. Oh, we're going to have to learn a whole new thing. But it means we don't need frame buffers, which means we might not need these image views. Oof, what do we do with that then? So yeah, this is what it's saying. This begin rendering got promoted in 1.3. It takes a command buffer and a rendering info. What does rendering info have in it? Rendering info has a render area, which in our case will just be the screen extent. Layer count, which we've just defined on our image view, did we? Yeah, on our sub-resource range. Layer count, view mask. Might be like aspect mask. Color attachment count, color attachments. Depth attachment, stencil attachment. Or the equivalent from before version 1.3. Let's see. If there is an instance of VK device group, okay, so we're not using a group render, so we don't care. If multi-view is enabled, which again we don't care because we're not doing multi-view, each element of the color attachments array corresponds to an output location in the shader, i.e. if the shader declares an output variable decorated with a location value of X, then it uses the attachment provided in P color attachments X. If it declares an output variable decorated with a location value of X, and what X is just an index into this thing. If the image view member of any element of P color attachments is a null handle and resolve mode is not this thing, it writes the corresponding location by a fragment are discarded. So it doesn't error, it just discards. So you still take image views, do you? Okay, this VK attachment info, I guess, will have an image view on it. Scroll, scroll, scroll. Rendering flag bits. Suspending, resuming. Not what we were after. There we go. Rendering attachment info takes an image view and an image layout. Is that the layout it is or the layout? Okay, so you have to tell it the layout it will be during rendering. And I guess we have to use something to do those image layout transitions. Resolve image layout is the layout that resolve image view will be in. Where resolve image view is an image view used to write resolved data at the end of rendering, or image view with a view that we used for rendering. How this will be resolved into a resolve image view. So I'm assuming we can just say leave it alone and we just have the one image. And then we're into extensions. Endless extensions. Get rendering area granularity is all in a future version. Although we might actually need these now for these rendering areas. Okay. And then command end rendering. Command buffer is the command buffer in which to record the command. We keep scrolling. Any of this interesting? More extensions. And then it gets to the end. Wow. I wasn't expecting that. I'm not really sure what we do with this information. Because one thing we could do is ignore it and keep going the way that I've done it before. Or we can try and do this new thing. I think we'll try and do the new thing. Because like I say, it seems a shame, since we're trying to learn how to do this. I say we. I'm trying to learn how to do this. I assume maybe you're here because you're also interested in learning about it. It would be a real shame to spend a load of time learning the old thing, only to find that nobody uses it anymore. It's deprecated everywhere and not supported on hardware. Which is all to say that I think I'm going to keep. That we want to keep. We didn't add a frame buffer. We're not going to need a frame buffer because that doesn't exist anymore. So we've got our image views, and that's all we need. We will need at some point something to recreate these when the when the window changes size. But again, I think that has to fit in somewhere in our command handling in our main loop. So maybe actually we say forget about frame buffers And our next step will be to go back, if I remember right, I did put a thing on it, to this list. Because basically what we need to now do is set up all of the rest of these things, right? We need to set up a set of resource descriptors for our, I think, shaders count. I think our textures will count, I think. Do our images we write out to count? I'm not sure. We're going to need to make a graphics pipeline. We're going to need a command buffer so that we can actually submit work, which will include things like transferring data around, and these image layout transitions I think will involve commands. That might be the next place that we go, is try to work out how to make a command buffer and use it to transition our Swapchain images to something appropriate. Although again, it sounded like that's something we now do as part of this new render thing, so maybe we'll worry about that later. Oh, it's really thrown me for a loop. Does resource creation include shader modules? Where's resource creation? Chapter 12. Ah, you get your own thing. Yeah, I'm not sure what we do next. So now we don't need these frame buffers. I'm going to say command pool seems like a sensible next place to go. We need to start setting up commands. We're going to need to start setting up a descriptor pool and then creating shader modules so that we can submit work to run a shader that uses those descriptors. Then we need to hook that into our main loop so that we can render images to the screen or present images to the screen each frame, and then we have a rendering pipeline. Okay, I think that's going to do us for the day. It's a small step, but a necessary one. With a bit of a bombshell twist that the thing that I thought I was going to do next is deprecated. So we can look forward to more head scratching in the future. But I'm going to call that a day. So I hope you've enjoyed things, and I'll catch you on the next one.